Good afternoon, ladies and gentlemen. Welcome to this 1 o'clock talk this afternoon, and it's about a real-world use for blockchain. I'm not going to do slides. I know everybody loves slides, and you all want to watch lots of slides, so I'm actually doing this from Visual Studio Code. I love Visual Studio Code, Markdown, so this will probably be the only presentation you'll see done in Markdown today. So first of all, blockchain. Hands up who's heard of blockchain? Who hasn't, right? Hands up who think there's a lot of hype out there. Right. There is a lot of hype about blockchain, what it can do, what it can't do, and so on and so forth. This is actually a very simple use case for blockchain. I'm going to go through how you can actually use blockchain to do attestation and certification of documents, in particular office documents. So this is actually how you can use the public blockchain, not a private blockchain. I've done a lot of work with blockchain over the last 6 months, and at the end I'll talk very briefly about the pros and cons of what can be done and what can't be done, and what you can actually do today and what you can't do today. This you can do today, and it is a very powerful mechanism for using blockchain. Blockchain is really, for the simple one-liner on blockchain, it's a shared, attested proof. It's a proof. It's a mechanism where you can actually prove that something has been put onto the blockchain and is not moved, has not been changed. So that's what this actually does. So what we're going to do is we're going to actually take an office document and we're going to put it up onto the blockchain. So first of all, what does that actually look like? I'm actually using a standard back-end set of APIs that actually go onto the public blockchain. The standard is called Chainpoint. It's actually an implementation by a company called Stampery. You'll see them a bit later on. And what we do is we hash the documents. We SHA-256-512 actually, the hash. We put it onto both Bitcoin and Ethereum, and then we can go and read that back later on. So let's see what that looks like in terms of the end user. So the idea here is you've written a contract. You want to make sure that that contract in 10 years' time, people realize that is the same contract. It is not being changed. It's not being manipulated. We do that by putting the blockchain, the contract onto the blockchain. Clearly, if we put the whole of the contract onto the blockchain, it's going to take a lot of space, take a lot of time, and so on and so forth. So what we actually do is we hash the document, put the hash on, and then we read the hash back and check the hash when it comes back. So here's an office document that we want to actually put up on the blockchain. It's a contract, a standard contract. This is standard Office 365, as you can tell by the adverts, and it's the usual legalese, which I don't understand, right? So what we're going to do is, first of all, we have to put the add-in in to do this. So we've got an Office add-in, and we add the add-in using managed integrations. That does a load. Or not. There's a flying start. Let's just stop that and give that page a refresh. I'll swear that's the right address. What? Okay. You're right. I thought I said use another account. Okay, I'll use my my corporate account then. Oh, shoot. Sorry about this. My apologies. I don't understand why that's not working, right?
Outlook.com, not to Outlook.365.
It's Outlook.com.
Outlook.com. No, go to Outlook.com. Just type Outlook.com in the address.
You're right.
.com.
You're right. Thank you. Sorry about that. Wrong. Was going to my corporate address. Okay, so let's go back and start again. We take this contract. We're going to add in integrations. Okay, and we can look at the add-ins. And we want to add a custom add-in. We're going to add it from URL. Now, the URL we use, because I haven't got this up on the store, the URL I'm going to use is actually is this manifest URL. Okay, so this is we have to add in a manifest, so we tell Office where to look for the code. This is the Office manifest, and we'll come back later on to look at this. Okay, and so we go in here, we add in the manifest, we go OK, and we do install. It gives us a warning now to say that, should give us a warning. Okay, so it's done the install, right? And we've now got our custom add-in in here. All right, and we'll go and have a look at that in a little bit more detail. So here's our contract, and you can see up on the top right-hand side, we have a little stamp icon, right? So now what we can do is we can take our document and we can stamp it. And first of all, we have to certify. So what we do is we take that document, we actually take the text of the document, we hash the document, and we put it up onto the blockchain. And you can see there it said it's successfully stamped. The next thing we can do is we can go and verify that the document's stamped. Now, blockchain actually takes a while. So typically, blockchain, depending on which blockchain you're using, it takes between 2 to 3 minutes up to 10 minutes to actually certify it and put it on the chain itself. So this may or may not work. This is one of the joys about doing things on blockchain. It's asynchronous. Okay, so you can see that it's still working on it. So what I'm going to do now is I'm going to go away and I'm going to show you the code. And actually, we'll come back later on and actually see that attestation worked, right? A couple of other things I wanted to show you. This is actually Ethereum statistics, and this is showing the blocks that are being put up there. So what's happening is my hash is being taken with all the other stuff that's being put out onto the Ethereum blockchain and put up onto the block up there. That's the last block that was put up. You can see how often this is going and how often the blocks are being put up. You can see on the middle there, last block is how often it's creating new blocks. The miners are going and creating blocks, and they're putting the blocks up onto the chain. Okay. Should have finished by now. Anyway, let me go and have a look at the code first of all. All right, so the code is actually very simple, and it consists of 3 parts. Looking over here on the left-hand side, first of all, what Office needs is it needs a manifest file which says where that stamp's going to come up and what you're going to do. Office is actually pretty good because what it does is it actually allows you to run JavaScript code back in the actual. Here we are. It actually allows you to run JavaScript code in Office itself, running on your machine. So the document never leaves your machine. It's always worked on your machine. Office actually does the hashing for you. Only the hash leaves your machine, so it's very private. So what happens is that this is actually the Office manifest, which we saw a minute ago. I took the code for that, code position for that. And you can see here what it does is it puts the stamp up and then just calls this function prove down at the bottom here. So then if we go and have a look in the functions, again, this is actually running as JavaScript in Office itself. And you can see here we have a approve event. What that does is it goes up to collects from Office, actually, on this hash mail thing here. Let me just show you where hash mail is. OK. Hash mail. Basically, hash mail gets the mailbox body itself, OK, gets the text, and then creates a hash from that and sends it back here. This is the hash, using a SHA-512 algorithm here to create it. OK, then it takes that hash, and what we're looking at here is we're actually looking at the proof, not at the stamp. We're looking at the proof, the latter one. So what it does is it gets the hash, goes off, and then looks down here to see what the response is, asks for the response back. We'll come back to have a look at that in a minute. Looks for the response back and says, OK, is that the same as what I've got? Right? We actually have a little lookup table, and this is something that you have to be aware of. Very often in blockchain, you need to do some sort of off-chain storage, right? Very often you want to store information locally, like the document, for instance, that we've built. We're not going to put that document out there, which means we still have to store the document somewhere, right? So one of the big areas about blockchain is off-chain storage, and you'll hear that come up a lot. So then next you see we've got the actual the proof comes back, and we check both the blockchain BTC and Ethereum, because we're putting stamps out onto both chains. And what we then do is we wait to see which one comes back, and we put up the message to say that they've come back. And you can see down here the message I saw earlier on, which says still working on it. So now, hopefully, if we go back and have a look at my Office, if I now go and do another verify, you can see the Ethereum blockchain attested the content of this email as of May the 11th, and so on and so forth. So it's actually gone and stamped it. The proof I just showed you went away, checked that my hash was the same as the hash that is out on the public blockchain, checked the two and said that this document's now been stamped. So now if anybody goes and changes anything in the document and then restamps it and then tries to verify it with my stamp, it's not going to be the same, and it will say it's not the same. Okay? So that shows you, as I say, how the front end piece of this code works. Let's have a quick look at the back end of it now. Where are we? So what this does is this function actually then just calls out to a Node.js piece of code here. Okay? And the Node.js code is running on Azure. And you can see here, we have well, actually, down at the bottom here, you'll see that that's the stamp. Here's the proof. Okay, so you come in here. You're looking to see if the stamping already exists in the proof in a dictionary that we keep. If it doesn't, we send the stamp not found, and so on and so forth. And then what actually happens is that then we take that and we go and call the Stampery APIs. Stampery originally was a set of APIs they generated, but actually we've changed it now so that there's a REST API following on from this code. And you can see here, it goes through, it sends out for the proofs, it then checks the chain, it checks the proofs dictionary against the Ethereum chain, it does the same thing for the blockchain down here, and if it gets them both back, then it will give you a message going back saying that that was a valid stamp. I still don't have the blockchain value back yet. As I say, Ethereum takes about 5 minutes, blockchain takes about 10, and if we go and have a look at we actually generate, Stampery generate a document, a certificate here, and this is really a mock-up, but with the interest of what's actually happening under the hood. But what you see is you see my data hash for the document up there. You see my Ethereum root transaction gone down with the transaction ID here, and I still don't have my Bitcoin proof. Bitcoin's very slow today. I don't know why. It was good first thing this morning, but it seems to be going very slowly at the moment. So that gives you a quick idea of what the code looks like. And we've gone, I think we've done all the way through. So we started off Office document running, JavaScript running inside the Office document that goes out to Node.js, running on Azure, and in fact, if we look, we should have this one. So you can see here, this is Azure. This is Azure console, and you can see the requests being made here. This was the one I did for a test earlier on, and then that was the one we just did a minute ago, right? So this is probably when things went wrong with the demo, I should think. And so you can see Azure's processing through and so on and so forth. So that gives you a quick idea how you can build something using the public blockchain. It's very powerful. You can pretty much attest to anything. You can do any document, any digital document. It can be a photo. People are using it for things like identifying diamonds, for instance, is another one. As I say, any Office document, I've shown it here in Outlook. It obviously works in Word, it works in SharePoint, so on and so forth. Very simple use case, but very, very powerful. Lots of reasons why you'd want to be able to guarantee that something is correct or isn't correct. All right. So let me just wrap up with the lessons. Blockchain is a secure, shared, distributed ledger. That's all it is. It's just a ledger. It's a database that's effectively a database that's shared across lots and lots of different nodes. Because it's shared across lots of nodes, it's pretty well guaranteed. The common use cases, the first one here is affirmation, and that's the simplest. The other two that are very common is exchange, where two parties want to exchange contracts or exchange things like land registry details, things like that. And then finally, there's this idea of some sort of chain, typically a supply chain. A lot of people want to do supply chain, where it goes from one person to another, and you want to make guarantee that things are correct all the way down the chain. I'm doing one with agricultural produce, where you want to guarantee that there's no pesticides in it, for instance. So that's the sort of use cases there. Some of the issues, first of all, scale. A private blockchain doesn't really make a lot of sense. If you're running your own blockchain, it really doesn't make a lot of sense because you can actually go and change that yourself then, and really you'd be much better off with a database. Where blockchain comes into its own use is where you have a consortium, different people you don't necessarily trust, and you want to be able to work with them. You can use blockchain for that. And then there's the public case, which I'm showing here, where you're just using a public area to store things, right? Couple of issues. First of all, size. You don't want to put a lot of stuff on the blockchain. You get charged to put stuff on the blockchain for a start, one way or another. And so the more stuff you put out there, then the bigger the chains get. I think Ethereum's about 80 gig at the moment, and we really don't want to get the chains too big. A lot of issues with scalability. What are we going to do when the chains get very much bigger? So the idea here is, wherever possible, to do things off-chain. Again, if things go on the blockchain, they're publicly accessible, so you need to hash things before you put them out there, which is what I showed today. And the third area is the whole area of proof of work. You have to have miners on a blockchain. People, especially on internal systems, they don't want to have miners. So there's a lot of work going on around proof of stake. A lot of work, most people today are getting into blockchain, and they're tending to look at the infrastructure side of things. Setting up blockchains is relatively easy. There's certainly, we have a thing called Project Bletchley for Ethereum on Azure, for instance. It's a pretty easy thing to do, but actually it's not really necessary. You're much better off using some of the test chains that are out there or the public chains. It's really easy to get sucked into, let's set up some blockchain infrastructure, and you'll spend a lot of time doing it because the technology is really new. It's like saying, hey, let's go and build let's set up our own database from all the pieces. Don't do it, right? If you want to learn how to use the blockchain, use the public ones, right? Of course, if you're interested in blockchain technology, like Merkle trees and all those sort of good things, then absolutely go and do your own. Finally, there are a number of enterprise issues that take work, right? And I didn't really show them in this particular application. So there's identification, ID, authentication, key management, and monitoring. All those things for individual parts of blockchain take quite a lot of work to do, which is why it's nice when you do an easy case like this. So the code story is up there. This describes how it's all done, and the code itself is up on GitHub. So those are the two links you need. And if you go up here, you'll be able to see this is the code story under Microsoft.com/real-life code, and it has some of my really poor graphics in here, which shows the architecture, which I've talked you through, shows the implementation, and so on and so forth. The code itself, if you want to go and use the code, is actually up on GitHub. It's up here on Stampery's GitHub page, stampery.com/office. Go and pick it up, reuse it. It'll give you a good idea how you can go and build your own thing in blockchain.